metric 1035.
And I, Muhammad Faizul bin Muhammad Nil. My number metric is 1055.
And also my name is Muhammad Muizzullah bin Sirajuddin, and my number metric is 1019.
So let's start our presentation.
Okay. So the introduction is differentiation is a method of finding the derivative of a function. Derivative is a process in math where we find the instantaneous rate of change in a function based on one of its variable. The most common example is the rate change of displacement with respect to time, called velocity.
Stationary point. Stationary point ni ada 3 bahagian, 3 type. Max point, minimum point and point of inflection. For a formula, basic differentiation formula, dk dx sama dengan kosong apabila k sama dengan constant. dx d kurungan x and dx sama dengan 1. D kx per dx sama dengan k. When apabila k sama dengan constant. D xn per dx sama dengan n x n tolak 1. Okay, for a diagram, maximum and minimum, maximum the diagram to the height, like for a minimum, the diagram go to the low and is smile. For the curve of discretion, dy dx lebih kecil pada kosong. For stationary point, dy dx sama dengan kosong. For the curve of disgrace, dy dx lebih kecil pada kosong. Okay.
Okay, so I'm Muhammad Abdullah and my part for this presentation is for question. So here the question 1. The given is y equal to x squared plus 3x minus 2. So in application of differentiation, we have 4 steps to solve the equation. The first one is we need to differentiate the equation. So by the equation x squared plus 3x minus 2, we got the differentiation is 2x plus 3. That's the answer for step 1. After that, we continue to step 2. Step 2, we need to minus to change our dy dx. So the equation will equal to 0. So we can get the value of x. And after that, after we get the value of x, we continue to find value of y. Next step is step 3. For step 3, we take from equation step 1, 2x plus 3, and we do the secondary differentiation, and we get a value of 2. And we equal it to find the stationary point. So 2 is more than 0. So the value of x and y, we got negative 1.5 for x, and y we got 0. So this look for a minimum point. So we have one more method how do we get the minimum point or maximum point. Looking for equation. So for the equation is we got a positive x squared. If we got the from equation is positive x squared, that means the stationary point is minimum point. If we got a example like minus 2x squared, so from that we can know the stationary point and the graph will be maximum point. Okay, so here the sketch graph for step 5. So after we got the value, and then we need to sketch the graph, and we got negative 1.5 for x and 0 for y. And we label it to the first equation, y equal to x squared plus 3x minus 2. So that's for equation 1, and we solve the problem using application of differentiation to sketch the diagram.
Okay, 2.9, perform application of differentiation in real problem. Introduction. There are various applications of derivative not only in math and real life, but also in other fields like science, engineering, physics, and more. In previous class, you must have learned to find a derivative of different function like trigonometry function, implicit function, logarithm function, and more.
So for the equation 1, so the equation is Nico bubbles blowing machine blow spherical bubbles whose surface area increase at the rate of 25 cm to per second. What is the rate of increase of the radius of a bubble when its radius is a 3 cm? So step for we calculate. So first we can see the dA over the dt equal to 25. We take from the equation. Other than that, we know the formula of area is 4 pi r equal to is surface area of sphera. Other than that, we put in on the rumus the formula. So the dA over the dr equal to 8 pi r. So we know the r is 3. So and then we just put in. So it can be dA over the dr equal to 24 pi. Other than that, so the formula is for surface area is dA over the dt equal to dA over the dr times dr over dt. So the formula is dA over the dt equal to dA over dr times dr over dt. So we know the dA, we get it so dA dt we know it 25 equal to 24 pi times dr dt. So we just twist it from dr to dt, put it in front, and 25 put it that side. So it can be dr over dt equal to 25 over 24 pi. So the final answer we get the rate of change of the radius is 0.33 cm.
So for the conclusion, the application of differentiation is widespread in various fields of mathematics, science, and engineering. Some of the common applications include optimization problems, finding tangents, lines, and rates of change, modeling real-world phenomena, solving differential equation, and calculating extreme value. So the mathematics needs to know about differentiation. In our life also need a mathematics to solve some problem. So here the conclusion that we can get from differentiation of application in our presentation. So that's all for us. Thank you.